So let's get started with the solution. So we're going to start with this triangle right here. For that triangle right there, according to SOHCAHTOA, that is the opposite, that is the adjacent. So tangent of 28 degrees equals opposite over adjacent. Oops, excuse me, that's backwards. Equals opposite over adjacent. I'm going to solve this equation for y. You will see the reason for that later. One way to do it, stick a 1 underneath here, cross multiply. I get y times tangent of 28 degrees equals 1 times 1,000. Trying to get y by itself, so I'll divide both sides by tangent of 28 degrees. Excuse me. And this is what y is equal to. Y is equal to 1,000 over tangent of 28 degrees. Okay, now that we have that, now we're going to look at the other triangle. The other triangle is also a tangent, because for the other triangle, we also have the opposite side, and we're interested in the adjacent side. So we have tangent of 21 degrees equals opposite over adjacent. Now I'm going to avoid putting the tangents into the calculator and rounding them. So here's how I'm going to handle this. I am going to, again, cross multiply. I'm going to get x plus y, that entire quantity, times tangent of 21 degrees equals 1,000. Then, these are being multiplied. This stuff's being multiplied by the tangent. So I'm going to divide both sides by tangent to get that away from there. Those will cancel. And it leaves me on the left with just x plus y. On the right side, I have 1,000 over tangent of 21 degrees. Now remember, we're trying to solve for x. So I'm going to subtract y from both sides. That will give us the expression for x, which is what we're looking for. So x is equal to 1,000 over tangent of 21 degrees, and then all of that minus y. Well, that is why we figured out what y is, because we're going to need to put that right there. So I'm going to transform this equation, and I'm going to write it as x equals 1,000 over tangent of 21 minus the thing that y is equal to, which is 1,000 over tangent of 28 degrees. I will throw that into my calculator, and once I get that into my calculator, I will have the answer. Well, I happen to have already done that, and my answer for x is 724.362, etc., etc., etc. I believe the question said to round to the nearest tenth, and so that rounds to 724.4, and that would be 724.4 feet. And that is one way to solve this equation. Not by any means the only way. There are multiple ways that we could do it. Okay. This next part is completely optional. If you're okay with that answer, you don't need to see anything more. But we're going to look at something else if you're interested. So, from geometry, which you may or may not have learned in some previous course, there is a rule about two parallel lines being crossed by a third line. This angle, this angle, this angle, this angle, in this case the smaller angles, all those four smaller ones, Those are all equal to each other. They are all the same size. That's always true. And the larger one, the larger one, the larger one, the larger one, those are also always true. This is a fact known from geometry. So the small ones are all equal to each other. The large ones are all equal to each other. What's the point? Well, let's go back to our original drawing. We had the valley. We had the 1,000-foot part here. We had the horizontal line we need to draw so we could talk about angle of depression. And then we had the line that went from here down to there. And we knew, for instance, this one, let's say, was 21 degrees. Now, if you extend this line some and extend it some the other direction, and I suppose let's do also for the others, you see that you have two parallel lines crossed by another line. And this angle right here and this angle right there, those are this one and that one. They're equal to each other, which means this one down here is 21 degrees. And so if you wanted to, you could use this triangle instead of the one that we used before. Let me go back to our original picture and let you know what it is that I'm saying here. So you got the 1,000-foot, you've got the valley down below, you've got the horizontal line above, and what did we really have? We had two different triangles going on here. We knew that this one was 28 degrees, and we knew that this one was 21 degrees. And so, by what I was showing you a moment ago, that tells us that this is also 21 degrees, and this is also 28 degrees. And so, if we wanted to, we could have used this as one of our triangles, and we could have used this as our other triangle. It still would end up giving us the same thing. It would still basically be the same triangles, but it's just a different way of looking at it. Okay, so that is it, and that is the end of this recording.